This is Britt Caswell with another example problem. In this problem, I came up with it, and it's a word problem that shows us how to use quadratic equations to model a falling object. So in this problem, there's 3 squirrels that are 50 feet in the air in a tree, squabbling over an acorn. One squirrel donkey kicks the other, who then drops the acorn. It falls out of the tree, bounces off of a picnic table, which is 2.5 feet off the ground, and then hits the ground. Alright, so we can model this situation using the following formula, where the height of the acorn is denoted by h. Recognize that h is talking about feet. And the time that has passed is denoted by t, which is in seconds. I didn't type that in there because there's a lot of words. And then we're using this equation. How long will it take for the acorn to hit the table? I also found a cute picture of some squirrels. You're welcome. So, in order to solve this, I first want to talk about the parts of the equation that you see here. So this 50 is the 50 feet that the squirrels are in the tree. So if I was like graphing this, here's our squirrels way up here in the tree. That's at 50 feet. Okay, so then they drop this acorn, and it's going to fall at this kind of rate. And then here at about 2.5 feet, it's going to bounce off and fall to the ground. So this initial portion is modeled with a parabola. Okay, anytime you have something falling in free space, like nothing's touching it, it'll fall like a parabola. Okay, and so that 50 feet is the initial height that it fell from. That's our c value. Alright, and then this -16, this is actually a scientific number. You'll see it a lot of times when we're dealing with problems with feet. It is the pull of gravity. So that's a very common number to have in these problems. Alright, so now let's talk about how to solve it. Well, we know that the table is 2.5 feet off the ground, so that's an h value. So logically, I'm going to take this h value and plug it in where the h is in the equation. And then I need to solve it. Now I know that when you guys are doing this in the book, these are really nice numbers, and you end up being able to factor this side if you really want to. I'm not so nice. I went with some more realistic values. Okay, so first thing, I need to try to get the t alone, so I'm going to subtract my 50. So 2.5 minus 50 is -47.5. And then I need to divide by the -16 that's being multiplied to the t squared. Oh, this is going to be ugly. Okay, and I'm getting a number, it's 2.96875. Now it's important to note that here, this needs to be a positive number, because to get rid of the square on the t, I need to take a square root. And until our next section, you haven't learned how to take a square root of a negative number. Alright, now remember, whenever you take a square root, to get rid of a square, you need to put a plus or a minus in front of that symbol, because it could be either positive or negative, whatever number comes out of there. Alright, now I'm trying to convince my phone to turn to the side so I can take the square root of that number. And I'm getting 1.723, essentially. And it's positive or negative is equal to t. So this is saying that there's two answers. They're saying that t is a positive 1.723, or t is a negative 1.723. 1.723. Okay, that's what that plus or minus symbol means. And we have to now think about the context of the problem to decide on this. Now remember, t stood for time, right? So does it make sense to have a negative time value? On our graph, a negative time value would be over here, which this squirrel isn't donkey kicking that acorn back in time, right? So this negative value doesn't work. We get rid of it. So this is the only plausible answer. So it would take approximately 1.723 seconds for the acorn to hit the ground. Oh, not the ground. What did it hit? It hit the table, right? And then it hit the ground. There we go. So word problem usually wants a word solution. Until next time.